Hey, good morning, Seminoles. Welcome to another exciting installment of Seminole Math. I'm Mr. Fuentes, and today we're going to be going over the rules of scientific notation. All right, let's get started. All right, so scientific notation, in order to correctly and successfully understand scientific notation, we got to follow three basic rules. Rule number one, okay? We must create a number greater than 1 but less than 10, okay, by moving my decimal. All right, so I must create a number that is greater than 1 but less than 10 moving my decimal. So for example, if I had the number 3,520, and let's think about money. I like putting 0.00, we're thinking about money. And I want to write this in scientific notation. The very first thing I'm going to have to do is move my decimal so that I can create a number that is between 1 and 10. So right now I have the number 3,520. If I move my decimal one time, now I've created the number 352. If I move my decimal again, now I've created the number 35.20, but this is still not between 1 and 10. Well, what if I move it one more time? Well, see, now I've created the number 3.52, okay? So we can successfully move my decimal so that I can create a number between 1 and 10 when I'm starting with a large number. Well, what if I'm starting with a very, very small number like 0.00035? Same rule applies. I have to move my decimal so that I can create a number between 1 and 10. See, now I've created the number 3.5. So we can successfully create a number between 1 and 10 when we start with a large number, and also when we start with a smaller number, okay? All right, rule number two. Rule number two is, if I have to move my decimal to the right, in other words, if I'm starting with a very, very small number like 0.00035, and I have to move my decimal to the right in order to create a number that is between 1 and 10, okay? Well, this tells me that I'm going to end up with a negative exponent, okay? Now, the negative exponent just so happens to be the number of times that I move my decimal. All right, so I have the number 0.00035. I created the number 3.5. We have to make sure we write times 10, okay? And I had to move the decimal 1, 2, 3, 4. I had to move it 4 times, so my exponent is going to be a 4. But because I moved my decimal to the right, I have to make sure that my exponent is a negative 4, okay? So, something to keep in mind. You move your decimal to the right, your exponent has to be negative, okay? Now, same applies when I move my decimal to the left. What if I have to move my decimal in the other direction? If I have to move my decimal over to the left, my third rule says that, let's say I were to start with a large number like 3,520, and I have to move my decimal to the left now in order to create a number that is between 1 and 10. Okay, I've created the number 3.52. Okay, we got to make sure we write times 10. Okay, and I had to move the decimal 1, 2, 3 times, so my exponent is going to be a 3. So now I've created, in scientific notation, 3,520 becomes 3.52 times 10 to the third. Okay, now, if I can follow those 3 simple rules, okay, I can pretty much do any scientific notation problem. But in the 8th grade, guess what? We have to start using the calculator now. So really, really, really important, and a lot of students overlook this, they miss this. If you're going to be converting from standard into scientific, then you have to make sure to press the mode button and change from normal over into scientific. So now I changed it to scientific. I'm going to press enter, okay? And I'm ready to go. So now that same example, if I were to type in the number 3,520 and I wanted it to output in scientific, I have to change to scientific mode and I press enter. And it gives me the number 3.52 exponent 3, which is exactly what we created when we counted how many times we moved our decimal. 3.52 times 10 to the third. Okay? Now, what if I start with a very, very small number like 0.00035? Do you think it's going to give me a -4 exponent? Well, let's find out. 0.00035. Okay, let's see what it outputs. 3.5 exponent -4. 3.5 times 10 to the -4th. Perfect. So now we can go to the left or to the right, get a positive exponent with a large number, get a negative exponent with a very, very small number. Okay? So, following these 3 simple rules, guys, you should be able to do any scientific notation problem that you're faced with. If you have any questions, go ahead and ask me if you see me around campus. Thanks, guys. Have a good one.